Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 10E. Myself, Sirali Gaur, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 10th World Conference on Information Communication Systems, Software, Security and Sustainability, World S4 2026, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK. The virtual event is being held through Zoom from 29th to 30th July 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have a total of 6 presentations. Each presenter will be given 12 minutes for their presentations and 3 minutes for question and answers. On the 10-minute mark, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, please write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of this session, Mrs. Sharmila Kunde. Mrs. Sharmila is a registered associate professor, BVMS, Sri Damodar College of Commerce and Economics, Goa, affiliated to Goa University, India. She has a total of 24 years of experience in teaching and administration. She has a vast experience in conducting training in IT and web based business tools. I welcome you, ma'am, and it would be an honor if you would like to share some words before we start the session today.
Can you hear me?
Ma'am, you are not audible.
Hello, can you hear me?
Yes, ma'am. All right, let's start with the presentations for today. For our first presentation, we have Daniel H.M. with the paper title A Reproducibility Study and Deployment Comparison of Two 5G and Beyond Research Testbeds, Open 5G with UER RAN SIM versus Open Air Interface. Dear presenter, you may start presenting.
Hi, good morning, good afternoon, good evening. Are you listening to me?
Yes, sir.
Yeah, okay, I'll share my screen, okay? Can you see my shared screen?
Yes, ma'am. Yes, sir.
Okay, thank you. Greetings all, my name is Daniel Marx. I'm from Federal University of Campina Grande, Brazil, and I'd like to thank you for the opportunity and the presence. In this presentation, I'll share with you our findings when comparing two different mobile network emulation setups. One uses Open5GS to emulate the core network, and we were on scene for the implementation of the radio access network and user equipment. And another uses an open air interface end-to-end implementation. This study aims to address a critical need in 5G and beyond research: reliable, reproducible emulation environments that bridge the gap between theoretical simulation and real-world experimentation. Traditional simulators, while scalable, fail to capture the physical layer required for advanced 5G features such as network slicing. In this work, we compared two open source 5G testbeds, Open5Gs in Runsyn versus Open Air Interface, to evaluate their suitability for academic and industrial research. The goal was not to measure performance, but document the implementation hurdles and troubleshooting protocols to better make these environments reproducible and help to surpass the identified technical barriers, adding value that is missing from existing literature. Previous comparative studies tend to focus on high-level theoretical metrics while treating the underlying infrastructure as deployment process as a black box. However, this work aims to provide transparent, practical guidance for researchers attempting to reproduce similar testbeds. Also, this paper prioritizes the reproducibility of the deployment process by including the actual problem-solving commands used. This includes practical solutions for complex issues, such as resolving the user plane tunneling protocol routing conflicts in Open5GS and stabilizing the Open Air Interface radio frequency simulator. Documenting troubleshooting protocols maps possible real-world symptoms to exact fixes, enabling a stable execution. Our first setup, Open5GS in Runsyn, is modular, lightweight, and emphasizes core network prototyping and rapid deployment. The second setup, Open Air Interface, has a full 3GPP compliant stack with high-fidelity physical and Mac emulation, supporting multi-slice and real-time experiments. Both setups were deployed on Ubuntu, but Open Air Interface was located on Docker containers. Detailed configuration fixes for routing, timing, and slicing identity alignment were needed for both setups. So this table shows some basic differences between the two considered setups. Open5GS and Runsyn have, at first, less complexity since they can be installed at bare metal and require less computational resources and installing effort. On the other hand, OpenAir interface offers greater detail, especially regarding the core multi-network function configuration and radio link simulation. In this work, the main deployment challenges included user plane routing conflicts between simulated devices and the external network. For example, user plane tunneling protocol routing conflicts occur when Runsyn automatically creates routing rules that often override Linux policy-based routing, causing a mismatch between the simulator's internal behavior and the operating system's routing policies. This issue can be mitigated by defining network paths, which stabilizes the emulation environment and helps prevent packet-level errors. Timing issues into radio frequency simulation that require receive to transmit time adjustments. Its required tuning is heavily dependent on the underlying hardware and environment since it prevents failures on the random access channel, helps to mitigate jitter and latency, and ensures test viability. Database latency in containerized environments, which requires longer request timeouts. In multi-container deployments, communication between the access and mobility management function, AMF, and the backend database, such as MySQL, may experience scheduling delays and virtualization overhead. If the AMF applies a strict timeout, even small database delays during non-access threat exchanges can cause the AMF to stop the process too early, leading to simulated device rejection. Increasing the timeout makes the AMF more tolerant of these virtualization bottlenecks. Although this additional delay would be unsuitable for commercial networks, in an emulated setup, it improves stability by allowing the simulated device to connect instead of going offline. And slice identity mismatches caused by differences between decimal and hexadecimal formats, which could prevent the device network connection from being established, especially in sliced networks. Our analysis indicated that Open5GS and RunSyn are more agile for core network prototyping, whereas OpenAir interface provides a more flexible and feature-rich framework for advanced run research, despite requiring more complex configuration. Open5GS and RunSyn proved suitable for service-level orchestration, while OpenAir interface stood out for its air interface fidelity and advanced run research. The study documented kernel and configuration level fixes that improve stability and reproducibility, an aspect often overlooked in prior literature. Our main technical contributions include addressing user plane tunneling protocol routing conflicts in Open5GS, improving OpenAir interface radio frequency simulator stability by adjusting process priorities and timeout settings, and identifying slice identity mismatches and timing sensitivities in virtualized environments. And future work could include a hybrid staged research path that begins with lightweight cloud-native cores for service orchestration, such as, for example, Free5GC and Magma. Progress to STR-based runs, such as OpenAir Interface or SRS Run for high-fidelity air interface studies, and exploring multi-service slicing behavior under concurrent slicing requests. In this case, the stabilized environments provide a foundation for future studies to investigate complex behaviors, such as how to emulate the network handles multiple simultaneous services requesting different combinations of network slices. So, this work provides a practical roadmap for researchers transitioning from simulation to emulation, ensuring reproducibility and accelerating 5G and beyond innovation. Ultimately, the choice between these platforms should depend on the research objective. Open5GS and RunSyn are better suited for service-level orchestration, rapid prototyping of mobile topologies, high-level network slicing, core network logic, or application layer performance, since it offers a more streamlined experience. OpenAir interface, in turn, becomes useful when the research requires probing the limits of the air interface or analyzing advanced features that rely on high-fidelity protocol analysis. Because RunSyn abstracts the physical layer, which can hide critical timing and synchronization issues, OpenAir interface is required to closely mimic true hardware deployments and accurately observe physical and MAC layer interactions. That's all. Thank you for your attention.
Thank you very much, sir, for your presentation. Um, it is actually a good study, but I think I slightly had some network issues in the beginning. So if you can just take back your presentation to slide number 6 and 7, because I had missed something there, if you don't mind.
Okay, moment. 6 and 7.
Yeah.
You want to explain these slides again? Is that?
No. I just wanted to see what is there because I think I missed a little bit of it. So this study that you have, of the two, the comparative study that you have done, um, how have you, like, on what basis have you come to your conclusion? Like, how did you go about doing this comparison?
Well, I started it uh, in a clean sheet, in a white canvas, since when I started to study these possible tools, I didn't know any of them. So I was based on work from another lab in my university that used it to study Open5JS and Runcing. But when I was going deeper in this setup, I was noticed that uh, some needs I had at the moment was not covered by this first setup. So I searched it online basically and find OpenAI interface. It's a more robust tool to emulate, especially the radio access network.
Okay.
Um, and so I decided to compare this both because in both cases, uh, Open5JS it has a larger documentation, so it's easier to find ways to implement for your needs. But where I'm seeing in OpenAI interface is not so easy to find
Okay.
such documentation. So we decided to compare these both setups to document better to help us to develop our experiments. So that's the path we we got until now.
Okay. So it was not an actual comparison that you have done in the lab, right? No, no lab setup. So this was basically based on the documentation available and literature review. Is
No,
that what
no.
you are saying?
My 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 initial research. Actually, I am researching another aspects of radio access network, especially security.
Oh,
But I needed to implement some emulation to study these security issues I found in previous works. So I implemented both setups in a computer environment, not in a physical environment.
okay. Okay.
So I
Okay. Got
used
it.
this both and decided to choose at that moment OpenAI interface to keep studying my main goal that's security of radio access network.
Okay. Got it. Got it. Okay. Yeah. Thank you, Mr. Marcus. And it's a nice study. And I wish you all the best for any of your future research work. Thank you so much.
Thank you.
Yes.
Thank you so much for that presentation. You may stop presenting your screen now. Now we have Rupali with the paper title Agentic AI Foundations Framework Security Applications. Dear presenter, you may start presenting.
Hi. So my topic is Agentic AI Foundations Framework Security Applications, and in this presentation, I'll explain what Agentic AI is, how it differs from traditional AI systems, the framework used to build it, its architecture, security concerns, and some of its real-world applications. So, agentic AI represents the next step in artificial intelligence, and unlike traditional AI, which only responds to prompts, agentic AI can understand goals, make decisions, plan tasks, and execute actions with minimal human intervention. Um, Unlike the traditional AI, which only responds to prompts, agentic AI can understand goals, make decisions, plan tasks, and execute actions with minimal human intervention. So we'll cover the foundations, architecture, major development, framework, security challenges, um, like and applications across the industries like cybersecurity, healthcare, finance, and robotics. So AI has evolved significantly over the time. We started with rule-based systems that followed fixed instructions. Then machine learning enabled pattern recognition, followed by generative AI. And the agentic AI represents a move towards goal-oriented autonomous agents that perceive the world, plan, reason about complex information, and act through iterative feedback loops, combining reasoners, memory systems, and tool interfaces. Frameworks such as LangChain, LangGraph, Microsoft AutoGen, CrewAI, Semantic Kernel have accelerated this development, offering modular architectures for agent coordination, memory management, and tool integration. So, to understand the agentic AI, we first need to understand intelligent agents. Most intelligent agents follow the BDI model, that is belief, desire, and intention model. So, beliefs represent what the agent knows about its environment. Desires are the goal that it wants to achieve, and intentions are the actions it commits in order to reach those goals. So, together, these components help an agent make rational and autonomous decisions. The large language models acts as the reasoning engine of agentic AI. The agent continuously follows a reasoning loop. First, it assesses the current situation, then it generates the reasoning steps, then decides the action and checks whether the goal has been achieved. And if not, the cycle repeats until the objective is completed. This iterative process allows the agent to solve complex problems step by step. So there are the two main types of agentic systems. A single agent system has one agent responsible for all decisions and actions, making it suitable for the simpler tasks. And in contrast, a multi-agent system consists of multiple agents working together, each handling different responsibilities. This improves scalability, collaboration, fault tolerance, and efficiency when solving complex problems. Um, so this slide shows the REACT paradigm, which stands for reasoning and acting. The agent first perceives the information from its environment, reasons using the LLM, and creates a plan, uh, performs the required action, and then finally learns from the outcome. So, this learning is stored in memory, allowing future decisions to become more accurate and effective. And this loop continues throughout the agent's operations. Memory is essential because it allows an agent to remember previous interactions instead of starting from scratch every time. So, short term memory stores the current conversation or task context. Then, the long term memory preserves knowledge for future use. And modern systems often use vector databases which retrieve information based on meaning rather than exact keywords, improving accuracy and contextual understanding. An agentic AI system is built using multiple layers. So the perception layer gathers information from text, images, sensors, or APIs. The reasoning layer processes this information and makes the decisions. The memory layer stores important knowledge. Then the action layer, which executes the task, while the tool integration layer connects with external APIs, databases, and services. And so together, these layers enable autonomous decision making. Now we have the frameworks. So several frameworks simplify the development of the agentic AI systems. The LangChain is widely used for workflow creation and tool integration. LangGraph supports complex reasoning using the graph-based workflows. Autogen enables multiple AI agents to communicate. Crew AI focuses on role-based collaboration. Semantic kernel, it combines the LLMs with enterprise software to automate the business processes and services. The Lemondex helps retrieve external knowledge efficiently. So each framework is designed for different types of AI applications. So this table compares the major frameworks. They differ in architecture, multi-agent support, tool integration, and common use cases. For example, the LangChain is excellent for modular AI workflows, and LangGraph is suitable for complex reasoning. Autogen and Creo AI are strong choices for collaborative multi-agent systems, while the Lamindex specializes in knowledge retrieval. And developers select a framework depending on the application's requirement. Since agentic AI can make autonomous decisions, security becomes extremely important. Some major risks include prompt injection attacks, hallucinations, misuse of external tools, and data leakage. A malicious prompt can influence the reasoning process, causing incorrect actions or exposing the sensitive information. And therefore, securing every stage of the AI pipeline is extremely essential. Several strategies help reduce these risks. Prompt injection can be minimalized by separating systems instructions from user input. Authentication and least privilege access prevents the unauthorized actions. Human oversight remains important for critical decisions such as financial transactions or infrastructure and management. And continuous monitoring, auditing, and encrypted memory further improve the system security. The agentic AI has applications across many industries. In cybersecurity, it can detect threats, analyze vulnerabilities, and automate incident responses. In finance, it supports fraud detection, market analysis, and algorithmic trading. Organizations such as JP Morgan and PayPal already use AI powered systems to improve the efficiency and security. As the technology matures, many more industries are expected to adopt these agentic AI solutions. So, to conclude, agentic AI represents the next generation of intelligent systems. By combining reasoning, planning, memory, and autonomous action, it can solve complex real world problems with minimal human intervention. And however, the future research must continue to improve the reasoning capabilities, strengthen the security, and ensure the responsible and ethical AI development. Thank you.
Thank you so much. Do we have any questions?
Thank you, Ms. Rupali. It was a very well researched paper on agentic AI. Since now this study that you have done, have you looked at any specific tools using agentic AI? Have you done any study on any specific tools for any of the applications? Or have you used any agentic AI tools?
No, I have seen the frameworks that I showed, that were LangChain, LangGraph, Microsoft AutoGen, Crew AI. So these were some of the frameworks that I have researched. But tools are like the OpenAI GPT models and other LLM tools that are right now in the market also. So those are some tools.
Yeah. So what do you think about Claude? The Claude, can it be considered to be a agentic AI? Like, does it have all these features which you have
Yes,
listed here?
Claude does have some, because it does think and reason and then give you the answer. So it does have agentic AI features.
Okay, just one more question on this autonomous decision making that these tools are being trained for, or these models are being trained for. In the future, what do you think, or in the near future, do you think this is going to become a threat, or it can be taken care of?
Yes, so as I said, there will be some security issues that will be arised, but
Hmm.
if we take proper steps to prevent all those security things, then I think it would not be that big of a threat if it is prevented.
Okay. Yeah. Anybody else has any questions? Okay. Thank you, Ms. Rupali.
Thank you.
Thank you so much for the presentation. Now, we have A.N. Gachahi with the paper title Antenna Miniaturization for Wireless Communication Applications Using Single Layer Capacitor Technology. Dear presenter, you may start presenting.
So I will be taking you through, I hope you can see my presentation.
Not yet, sir.
Let me try to share. Can you see it now?
Yes, sir.
Okay, I'll take you through my paper, Antenna Miniaturization Using Single Layer Capacitor Antenna Technology by Alex Gashahe and Lydia Gashahe from Technical University of Kenya, Department of Physics and Environmental Sciences. So, why miniaturization remains such a problem in wireless communication and electromagnetics in general? So traditional antennas, the antennas that we use today, that are already implemented in our wireless communications technologies, have one bottleneck that has been very enigmatic to solve. So the problem is that traditional antennas, the size of the antenna is directly proportional to the wavelength that it's supposed to transmit or receive, and hence miniaturizing these antennas beyond far beyond this size becomes problematic, in that you lose performance or incur costs in specialized materials. So this reduces this makes devices that are built not to be as compact as we would want. So we trade compact devices for the big footprints that we require for the traditional antennas. And also, as we try to miniaturize these antennas, we are also trading off efficiency and performance, and also costs. So our idea is to scrap the whole traditional antenna system and come up with a new element, a new basis for the antenna element that overhauls the principle that is already in use and puts in a new principle that allows the antennas to be miniaturized to a capacity that is not yet possible today. So to get to that point, we find that single layer capacitors offer this new approach. So single layer capacitors are simply the simplest, actually the simplest capacitors that we have, or the simplest capacitors that you can actually build. It's simply a direct link sandwiched between two metal plates. And when you pass an alternating current between the two metal plates, you set up what we call a displacement current in the dielectric. So this displacement current is what our antenna is based on. So by solving the Maxwell's equations around this displacement current, you can now get the 3D electromagnetic radiation that comes out of the single layer capacitor. And it's also important that the capacitor is actually single layer, because multiple layer capacitors pass current in different directions, thereby canceling out if any electromagnetic radiation that could be coming from them. So the physical model, as you can see in the first equation there for the displacement current, you can see that the displacement current is totally independent of the size of the element, and only dependent on the capacitance. The other important thing we have to note is the capacitive reactance, which is the resistance offered by a capacitor to the passage of current. And the third quantity that is important in this case is the LC resonance, which tells us at what point the capacitor radiates with the most efficiency. So from this, we set up a proof of principle experiment, now basing it on the theory that we have already established. And the proof of principle experiment consisted of 90 SLC single layer capacitors, an array of 90 single layer capacitors. And then we passed a signal between 1 and 30 kilohertz through the array, and then we measured using an inductive probe. We measured the electromagnetic radiation around the array. And what we observed is that there is a non-zero field across all test frequencies. The field strength varied with the excitation conditions, consistent with the displacement current predictions. So from there, we went forward and started to design a simulation platform, which we can now study the electromagnetic radiation around this element, so that we can now start to quantify things like the directivity, the gain, and the radiation patterns, to now enable engineers to design wireless communication systems around these antennas. So here we have some of our results. You can see there. The first one is the single element case, where this is simply one single element, and we have the radiation pattern with a ground present, which reflects back the other half of the radiation back to. And then without the ground, you can see the full 3D radiation. And then we have the second one is an array of single layer capacitors. And just as the first one, we have the first one without a ground, and then the second one with a ground plane that is reflecting electromagnetic radiation. So, as I said before, single layer capacitors are not they are not new to technology. They are actually the very first capacitors that were built, and so these capacitors are actually very available in the market today. So we went into the market and we sourced for data, actual industry data on several single layer capacitors that are already in the market. And we did an impedance analysis to help us with the understanding how the impedance of the single layer capacitors are and enable us in integrating these new elements into existing systems. Then from there, we decided to do a full integration of our wireless communication technology, and we chose Wi-Fi. And based on a very common chip, ESP32, which is a very common Wi-Fi chip that is used by most engineers and in very many development boards. So we integrated our antenna elements onto an ESP32 based test bed, and we collected the data on the signal strength and other parameters within that setup. So there we've presented a graph there showing the signal strength against the distance. So we took two ESP32s with different impedance profiles and then measured the signal strength from a common source around the same time and at the same space. And then we graphed them showing the energy, the expected energy decay as energy decays with distance. And also you can see that you have two impedance profiles showing the two impedance profiles of the test beds. So this study has been able to establish the theoretical framework that these elements can be based on or are based on. An experimental framework was also designed and carried out, proving that actually that the elements do produce electromagnetic radiation. And then a simulation platform has also been built to help now understand further the integration of these elements into existing technology. And an integration was actually carried out whereby these elements were integrated into Wi-Fi technology and studied on how they behave. So in conclusion is that we have been actually able to show that actually we have within sight a solution to one of the most enigmatic bottlenecks in wireless communication and electromagnetics, whereby by miniaturizing these antennas to that level, we can now we now increase the versatility of the consumer applications that are going to come out of the wireless communication now. So thank you. That is my presentation. Any questions?
Okay, thank you, Mr. Alex, for your presentation. And from what you have presented, I can understand that you have actually done some practical work and actually studied how or the effect of the components that you have studied,
Yes.
and the practical implications. So now what you have said is in future you could have antennas which are miniaturized for use in all these embedded and wearable systems, etc. But at present, I just want to know, what is the like now the antennas that are used or components that are used in embedded systems. They have slightly bigger antennas, is what you're saying.
What I'm trying to say is that there has been a very great effort in trying to miniaturize antennas. Actually, one of the enigmatic issues that is being dealt with right now is antenna miniaturizations. And there has been strides in this area, but the problem is in trying to miniaturize the antenna in the old framework, you either lose efficiency or you increase the cost, since you now need specialized materials
Okay.
to miniaturize the antenna.
Right. Yeah.
So yeah, and and even when you use specialized materials, uh, there is a point that you get to that you cannot miniaturize the antennas further in
Hmm.
this old framework.
Okay.
Yeah.
So what you're trying to say is now it would be possible to do it with more efficiency and at a lower cost, right?
Yeah,
If you use this.
what I'm trying to say is now you can do it without losing the efficiency or performance, and actually increasing the, because capacitors have been shown to be very, very efficient, up to 99% efficiency, depending on the manufacturing. And so you can now have, you now have an element that can actually up the efficiency rather than reduce the performance. And the single layer capacitors are quite small compared to, for example, at 2.4 gigahertz, which is the Wi-Fi frequency, you have an antenna of about 3 centimeters or around there. The single
Okay.
layer capacitors that we used in this integration are sub-millimeter, 0.6
Oh,
millimeters by 0.25 millimeters, which is a
okay.
phenomenal decrement in the size of the antennas.
Okay. Yeah.
Yeah.
Okay, that's very good, and all the best for any of your future research and applications in case you are contributing to it. Yeah. Thank you so much, Mr. Alex.
Thank you.
Thank you so much. You may stop presenting your screen now. Now we have Kazim Azad with the paper title Primary Information Processing in Information Services in Historical Perspective within the concept of information engineering. Dear presenter, you may start presenting. Okay, they don't seem to be responding. Next, we have Vishaka Shinde with the paper title Robust Digital Image Watermarking Integrating Deep Neural Networks and Cryptographic Security. Dear presenter, you may start presenting.
Good evening, ma'am. Is my screen is visible to all?
Yes, ma'am.
Okay, thank you so much. Okay, good evening, everyone. Respected session chair professors, researchers, and participants. Myself, Vishaka Shinde from Department of Computer Engineering and Technology, MIT World Peace University, Pune. Today, I am presenting our review paper titled Robust Digital Image Watermarking, Integrating Deep Neural Networks and Cryptographic Security. This review explores how deep learning and cryptographic techniques can be combined to improve the security, robustness, and reliability of the digital image watermarking. So let me begin with the introduction slide. So, digital image watermarking is the technique used to embed hidden information into an image without affecting its visual quality. And its main purpose is to protect copyright, verify ownership, and authenticate digital images. With the rapid growth of social media, cloud computing, and AI generated images, image tampering has become a serious concern. Therefore, security or secure and intelligent watermarking techniques are becoming increasingly important. Now we'll see background of the work. So traditional watermarking methods are mainly classified into spatial domain as well as transform domain techniques. So although these methods are very simple and widely used, they are vulnerable to attacks such as compression, cropping, rotation, and noise. So, to overcome these limitations, researchers have started integrating deep learning with the cryptographic security, leading to more robust and intelligent watermarking systems. My research gap is, so our literature review identified several research gaps actually. So existing method often suffer from poor robustness, low watermark recovery, the recovery accuracy, as well as weak encryption and limited support for real time as well as IoT applications. So these limitations highlight the need for hybrid frameworks, which motivate me to select this topic, and that combine the intelligent deep learning models with a strong cryptographic protection. Now, whatever the contribution has been done, this review provides a comprehensive analysis of modern watermarking techniques based on CNN as well as autoencoders, GANs, and diffusion models. It also reviews cryptographic methods such as AES encryption, which is highly used for the encryption, and blockchain based verification. So, finally, it compares different approaches using performance metrics and identifies the future research opportunities. Now, further, we'll see the foundation of watermarking. So, this modern watermarking combines three major components: traditional watermarking methods, deep learning, and cryptographic security. So why deep learning? So, deep learning improves the intelligent watermark embedding and extraction, while cryptographic techniques such as AES encryption and blockchain ensures the secure ownership verification and data protection. So, together, they provide the stronger resistance against the image manipulation attacks. Now, this is the deep learning architecture. This review discussed four major deep learning architectures. First one is CNN, which is used to extract the important image features for intelligent watermark embedding. Second one is, here I have added the uh, diagrams also. Autoencoders that learns both embedding and extraction automatically. In GANs, which improves the robustness against attacks by training a generator and discriminator together. And finally, this is the diffusion models represent an emerging technology for protecting AI generated image. This each architecture contributes to improving the image quality, watermark robustness, as well as authentication accuracy. This is the performance matrix. This performance of the watermarking algorithm is evaluated using several standard metrics, that is PSNR, SSIM, BER, and NCC. So this PSNR, which stands for peak signal to noise ratio, then SSIM is nothing but the structural similarity index measure. BER is the bit error rate, and the NCC is normalized cross correlation. So, with the help of this PSNR, it measures image quality. SSIM, which measures the structural similarity. BER evaluates the watermark extraction errors, and NCC measures the similarity between the original and the extracted watermark. This matrix helps compare different watermarking techniques objectively. Now, this is the research methodology I have used. A systematic literature review methodology was adopted. Research papers were collected from the reputed databases such as IEEE, Springer, ACM, and Science Direct. Only relevant and highly quality papers were selected for the analysis purpose. The reviewed techniques were evaluated using the benchmark datasets such as ImageNet, COCO, Div2K, USID, and BOSBase. So, ensuring the fair and reliable comparison. So, these are the data sets and their resolution as well as domain and common usage. This table I have included in my paper. Now, hybrid watermarking framework, which this comes under the future scope of my paper. This slides presents the proposed hybrid watermarking workflow, and the process start with the original input image. A CNN extract the meaningful features, These features are then processed by the autoencoder when the encrypted watermark is embedded. Before embedding, the watermark is protected using AES encryption to ensure the confidentiality. The watermarked image is then tested against the various attacks such as JP compression, cropping, rotation, and Gaussian noise. So here I have mention how this attacks can be happen, that cropping, how it happens actually, few adversarial attacks, how it looks after the attack tampering that image. So finally the watermark extract and verified. This framework improves both the robustness and the security while preserving the image quality. This is the comparative analysis table. So the comparison of the recent watermarking methods shows that hybrid approaches combining deep learning and cryptography consistently outperform traditional techniques. They achieve higher PSNR but lower BER and better watermark recovery and stronger resistance against the attack. So security evaluation demonstrate that these methods remain effective even after compression, rotation, cropping, and adversarial attacks, which is mentioned over here. This is the attacks, how that attack can be happen on the JPEG image. So image compression artifacts is mentioned over here. Then how the original image and the watermark image can be uh, seen after the cropping. Now applications. This hybrid watermarking has application in healthcare, surveillance, cloud storage, social media, digital forensic, and IoT systems. However, the challenges such as computational complexity, scalability, and protection of AI generated images still remain. So this is the GAN and diffusion watermarking techniques I have mentioned over here. Uh, these challenges used for the computational complexity, such as computational complexity, scalability, and protection of the AI generated images, still remain. So the conclusion, I would like to conclude this review to demonstrate that integrating deep learning with the cryptographic security significantly improves the digital image watermarking, and the hybrid frameworks provide the stronger copyright protection, higher robustness, and better authentication actually, authentication compared to the traditional methods. So, future research should focus on the lightweight AI models and explainable watermarking and secure protection of the AI generated multimedia. Thank you so much for your attention. Uh, any question?
Yeah, thank you, Ma'am Vishaka, for your presentation.
Okay.
Again, I must say that it is, something which is a necessity today, that this study that you have done.
Yes.
I just want to know, of course, you have said it's a review paper. So all
Yes.
those comparisons that you have done, it's based on, somebody else's study. You have, taken those papers and compared, right? So it is not that you have, or have you used any watermarking, tools to test what are the findings of those different papers.
Uh, Ma'am, actually, I am in the first stage of implementation only. So
Okay.
I'm trying to implement that tool so that I can find out such a adversarial attack. So this is
Huh.
just a review paper I have working on.
Okay. So how would you be taking this further?
Ma'am, actually, this will be for my PhD work. So,
Okay.
first of all, I will create one lightweight application
Hmm.
combining the hybrid technology of deep learning as well as cryptography, and then I will focus on the adversarial attacks for the to finding out the tampering of the image.
Okay. Okay, fine. Yeah. All the best for your PhD and a well presented paper. Yeah. Thank you so much.
Thank you so much, ma'am.
Thank you so much for the presentation. Now, Can we have Meghali Kalyankar with the paper title Secure Audio Visual Deepfake Detection Using Multimodal Attention and Adversarial Learning?
Yes, ma'am, Megali here.
Ma'am, you may start presenting.
Okay, ma'am, thank you. Is my PPT? Oh,
Yes,
hello.
ma'am, it's visible.
Okay, okay. Good evening, everyone. I am Meghali Kallankar, and today I am going to present my research work on secure audio visual deepfake detection using multimodal attention and adversarial learning. This work focuses on detecting fake videos and fake audio created using artificial intelligence. So begin with the introduction slide. This deepfake are AI generated fake videos or fake audio that looks very realistic. Using this deep learning, AI can make a person appear to say or do something that never actually happened. Today, creating deepfakes has become very easy because many AI tools are freely available. So deepfakes are used for entertainment and movies, but they are also misused for spreading fake news. So political manipulations, online fraud, and identity thefts. The example shown here demonstrate how difficult it is for humans to identify the fake content uh, because of this risk and efficient detection system has become very important. So these are a few videos I have added over here. So this is the few examples I have listed over here, which demonstrate how it is difficult for humans to identify the fake contents. Now, move to the further slides. That is introduction to propose work. So, existing defect detection methods mainly analyze either the video or the audio. However, modern defects manipulate both audio and video together. Therefore, analyzing only one modality is not sufficient. To solve this problem, we proposed MMADNet, which stands for Multimodal Attention and Adversarial Defect Network. Our framework combines several powerful deep learning models. Video MAE V2 extract the visual features. Hubert extract the audio features. Timesformer captures the temporal information between video frames. A multimodal core attention transformers combines both audio and video features. And finally, this adversarial consistency training improves robustness against the adversarial attacks. Now proceed further with the background work which I have done. So recent advancement in the AI have made deepfakes more realistic than ever. Modern deepfakes can manipulate faces, lip movements, voice, facial expressions, and emotions. Existing detection methods mostly focus on the only one type of data, either audio or video. So, because of this, they fail to detect advanced deepfakes effectively. And another challenge is detecting inconsistencies between audio and video over the time. So, therefore, there is a strong need for the robust multimodal detection framework. So the gap I found which motivate me to select this topic for my PhD work. So from the literature survey, we identified the several research gaps, like existing methods do not effectively combine audio video information. Then many models ignore the temporal relationships across the video frames. Feature redundancy reduces the overall detection performance, and most methods are vulnerable to adversarial attacks. Finally, many models performs poorly when tested on unseen datasets. So these limitations motivate us to develop a proposed MMAD net framework. So major contribution in the work of our work are follows as the first, we propose a robust multimodal framework called MMADNet. Second, we introduced a multimodal co-attention transformer for better fusion of audio and video features. Third, we develop hybrid HOA and COA optimization algorithm actuators to remove the redundant features and select most useful ones. Finally, we applied adversarial consistency training, which improves the resistance against adversarial attacks and enhances the model generalization. So this is the proposed MMAD net architectures. This slide shows the complete architecture of the proposed system, and the process begins by taking an input video. The video is divided into two parts. The first branch extract the video frames. The second branch extract the audio signals. Video frames are proceed using video MA V2, which learns the special visual features. At the same time, audio is processed using UBERT, which extract the speech features. Next, Timesformer analyze a relationship between consecutive video frames to capture the temporal information. After the feature extractions, both audio and video features are fused using multimodal co-attention transformer, allowing the model to learn interaction between audio and visual information. Then the HOA and COA optimization algorithm removes the redundant features and selects the most important ones. So during the training, adversarial consistency training improves the robustness against manipulated and adversarial samples. Finally, the classifier predicts whether the inputs is real or deepfake. So overall, this architecture improves the accuracy, robustness, and generalization. So this is the experimental setup to evaluate our proposed model. We use to benchmark dataset fake AV self and self DF. This dataset I have used. These datasets contain both genuine and manipulated videos. The proposed model was trained and tested using standard deep learning techniques. Performance was evaluated using accuracy F1 score as well as precision, recall, and AUC. So this is performance comparison. This table compares our model with the existing defect detection methods that AVFake net achieved on an accuracy of 91.2%. Then second one, MEVate achieves 93.8% accuracy. Then our proposed MMAD net achieved the highest accuracy of 96.4% along with the best F1 score and AUC. So these experimental results like this graph further validate our proposed model. The confusion matrix shows that the number of correctly classified samples are significantly higher. Curves indicates strong discrimination between real and fake videos. Overall, the proposed model consistently provides stable and reliable performance. So, uh, to conclude, we proposed MMAD Net, a robust multimodal defect detection framework which combines video MAV2, Hubert, Timesformer, multimodal co-attention, HOA and COA optimization techniques, as well as adversarial consistency training. The proposed framework achieves 96.4% accuracy, outperforming existing methods. It also demonstrated better robustness against the adversarial attacks and unseen defect techniques. So, therefore, it provides the effective solution for the real world multimedia security. So, the future scope in the future, this work can be extended to detect diffusion model based defects. We also plan to develop lightweight model for mobile and edge devices. Explainable AI can be integrated to improve the transparency. And finally, it continuous learning can help the model adapt newly emerging defect generation techniques. Thank you so much.
Thank you so much for that presentation. Do we have any questions?
Yes, thank you, Ms. Meghadi, for your presentation. And I think the work, like I was impressed with the kind of work that you have done. So this model, this for your PhD or something?
Yes, ma'am. This is my PhD title only. Means for PhD only, I have
So
published this paper.
okay, so it's like your model is almost tested and everything
Ma'am,
is
actually,
done.
my model is already trained with the existing database data sets, and I am
Okay.
trying to create my own data set so that I can again get the good result, good accuracy.
Okay, so that is your work is still remaining to be done.
One objective is remaining that real-time data set. By applying real-time data set, what will be the output? That task is pending, ma'am.
Okay. Yeah. So anyway, and even your future scope, for the work looks really interesting. So all the best for your, future research. And thank you so much
Thank,
for presenting.
thank you so much, ma'am.
Thank you so much. Now, I would like to call Kazim Asad with the paper titled Primary Information Processing in Information Services in Historical Perspective within the concept of information engineering. Dear presenter, you may start presenting.
Is the paper presenter there in the meeting? Is he there in the meeting?
No, I don't think he's present. Okay, for our last presentation today, we have Nguyen Huan with the paper title Application of Global Positioning System Software for Surveying, Mapping, and Establishing a Photo Interpretation course in Thuan An Ward, Ho Chi Minh City, 2026-2025, Vietnam. Dear presenter, you may start presenting. Dear presenter, are you there in the meeting?
I think she's there, but I don't know why. The name at least is displayed there.
Okay, then with that, I think we are done with our presentations for today.
Do you want to call her the name once more and check if she's there?
Yes, dear presenter, Miss Nguyen Huan, are you here?
Hello,
Yes, ma'am.
I'm Twix. I'm the authors of IDs 65 and 67. I will miss in the last presentation.
Yes, ma'am, you may start presenting now.
Yes, thank you.
Kindly conclude your presentation soon.
Measures. Can you see my screen?
Yes, ma'am.
Yes, let's start. Thank you. Hello, everybody. I'm Tuyết. I'm from Thủ Dầu Một University, Vietnam. On behalf of my group, I would like to present the topic assessment of land use change procedures under the provisions of the 2013 and 2024 land law in Thuận An War, Ho Chi Minh City, Vietnam. Our presentation includes 4 parts: introduction, the materials and methods, results and discussions, and finally is the conclusion. The first one, I would like to present the necessary of the study. Land use conversion plays a vital role in optimizing land resources and supporting socio-economic development amidst rapid urbanization. Although the 2013 land law established a legal framework for land use conversion, its implementation faced challenges, including complicated procedures, long processing times, and inconsistencies in administrative management. The 2024 land law introduced important reforms such as simplified procedures, greater transparency, decentralization, and improved administrative efficiency. Thuận An War, Ho Chi Minh City, Vietnam is experiencing rapid urban growth and increasing demand for converting agricultural lands to residential and commercial use, place significant pressures on local land administration. This study evaluates the implementation of the 2024 land law in Thuận An War through document analysis and questionnaire survey. It provides practical evidence to improve land use conversion management and supports effective implementation of the new legal framework. Next is the methods. In this study, we use 4 main methods to conduct this study. The first one is the data collection. We collect the secondary data from People's Committee of Thuận An War, Land Registration Office, cadastral records, land use maps, planning documents, and legal documents. Second method is the field survey. This method is used to verify land use status before and after conversion. Next one is the questionnaire surveys. The sample size is determined using a co-crunch formula with 100 respondents. The survey's topic is regulation awareness, processing time, administrative procedures, fees, certifications, and recommendations. And finally is the data analysis. The data will be analyzed using Microsoft Excel. Next is results and discussion. The first result is the implementation of the 2024 land law in Thuận An War. Table 1 indicates that the implementation of the 2024 land law has improved land use conversion management in Thuận An War. Compared with the previous periods, the new legal framework has simplified conversion conditions by eliminating the requirements for annual land use plans, reduce processing time from 20 to 13 working days to no more than 20 working days, and streamline administrative procedures. At the same time, land use conversion activities are expected to increase due to major infrastructure projects and the implementation of market-oriented land pricing. These changes have enhanced administrative efficiency, promoted investment activities and creating more favorable conditions for land users while strengthening the effectiveness of local land management. The next result is the surveys of people's satisfaction with the new landlord in Thuận An Ward. The questionnaire surveys focus on 5 aspects. The first one is the comprehensibility of the new relations. The next is the processing time for land use conversion applications. Next is the reasonableness of procedure fees. Next is the overall satisfaction with the implementation of the 2024 land law. And finally is the comparison of public satisfaction under the 2013 and 2024 land law. The recent results are presented in Figure 1 to Figure 5. In Figure 1 is the results of the level of comprehensibility of the 2024 land law. The picture shows us 76% of respondents found the new regulations essays easy to understand, including very easy and easy. The Figure 2 shows us the public assessment of the land use conversion application processing time. The same 76% of the respondents consider the processing time weak and very weak. No respondents perceive is as low. Figure 3 shows us the public assessment of the fee for land use conversion procedures. The results show us 55% of the respondents regard the fees as reasonable or very reasonable, while only 17% consider them expensive. Next is the overall public satisfaction with the implementations of the 2024 land law. 68% of the respondents reported that they were satisfied or very satisfied. And finally is the comparison of public satisfaction with the 2013 and 2024 land law. And the finally results are that public satisfaction increased markedly from 65 under the 2013 law to 85% under the new land law. On the results shows that the 2024 land law has enhanced the efficiency, transparency, and acceptability of land use conversion procedures in Thuận An Ward, contributing to sustainable land management and local socio-economic development. Finally, next is the discussion. Although the implementation of the new laws has many positive changes, however, it has some disadvantages that needs to be overcome. The first one is the incomplete land database. The second one is the limited understanding of legal regulation. Next is the inconsistent qualities of administrative services. Next is the ambiguity in legal revisions. And finally is the increase in land use fees. In order to overcome these disadvantages, our papers propose some recommendations, including the first one is developing digital land database and online services. The next one is to strengthen legal dissemination and public guidance. Next is ensure transparency in land valuation and financial obligations. And finally is enhancing community participation and interagency coordination. Finally, its conclusion. The 2024 land law has enhanced administrative efficiency, transparency, and accessibility of land use conversion procedures into and war. Continued improvements in digital infrastructure, legal guidance, and consistent public policy implementation will further strengthen land governance and support sustainable socio-economic development in Vietnam. However, my study have some limitation, including limited scope and sample size, limitation of analytic methods, and short-term perspective. So in the future, we would like to expand the scopes of multiple provinces or cities in Vietnam. We may apply advanced statistical and economic methods to identify factors influencing public satisfaction, and also conduct long-term studies to evaluate long-term impacts on the efficiency, transparency, and sustainable land governance. That's all for my presentation. Thank you very much.
Yeah, thank you, ma'am, for your presentation. The study that you have done and you have given the recommendations, would you be actually submitting these recommendations to your government?
My study the findings in my study is that suppose some find out some advantage and disadvantage of the new land law in Tung An War. So that's based on these findings. We also suppose some recommendations for the government. That's that's necessary to enhance the efficiencies of the new laws in the future.
Okay. And you have mentioned that there were some challenges like the digital land databases need to be improved, and also develop digital infrastructure is, I think, what you have recommended. So have you all done any study on what is the existing data that is available with your government or on your any websites? Do you have any government websites where this data is available?
This advantage is find out based on the questionnaires. Just based on the results of the questionnaires surveys. Yes.
Okay. Thank you so much. All the best.
I have another paper.
Yes.
Yes, may I continue, Kristen?
Yes, you may continue.
Yes, thank you. The next topic is the application of global positioning system software for surveying, mapping, and establishing a photo interpretation course into Angkor, Ho Chi Minh City in 2025, Vietnam. Our presentation also include 4 parts. First one is the introduction.
Excuse me, ma'am. Before you start, can I just request you to put it on slideshow, because otherwise it's very difficult to read the content on the slide. If you can just put it in the slideshow mode, it would be better. Yeah, thank you.
Is that right? Yes.
Yes.
Building management, operating and exploiting the National Land Information System is one of the 18 contents of land management in Article 20 of the Land Law of Vietnam in 2024. Especially in the context of Tung An War being marched into Ho Chi Minh City from the 1st July 2025. The strong urbanization process has rapidly changed the land use structures in the local low quality, creating an urgent need for timely and accurate updating and management of the upland data. However, traditional land use surveys are time-consuming, costly, and difficult to update frequently. Another difficulty is that interpreting satellite image without supporting field data can easily lead to errors in identifying land use types, directly affecting the quality of current status map and land management decision at the local level. Therefore, interpreting GPS, remote sensing, and CIS is necessary to improve the efficiency and accuracy of land use mapping and management. That's why our studies is conducted. In this study, we use the methods of collecting documents and data. These following documents and data are collected includes scientific article, research reports, and documents dashboards related to image interpretation and GIS application development. A satellite image rough and were obtained from Google Maps and Google Earth. Administrative maps data and page maps used for editing and building maps on QGIS and Google My Maps. The next method is surveys and mapping methods. In this study, we collected a total of 149 field samples. The samples were divided into 5 groups: water resources with 27 points, transportation lands with 33 points, agricultural lands with 27 points, residential lands with 28 points, and vacant lands with 34 points. The location of each sampling points were determined and its coordinates recorded using a GPS mass camera application on a mobile device with a positioning accuracy of 3 to 5 meters. The next method is used to realize boundary layers on Google My Maps. And you see in the screen is the workflows for extracting and mapping to an gross boundary with 7 steps. The first one is upon QGIS and as Vietnamese administrative boundary lines to the layers panel. The next is selecting who and work in Ho Chi Minh City. Next, save the selected figure. Next is to export the crops layer, and then save a layer, filter layer. Next, to go to the Google My Maps, and finally, the core boundary is successfully imported and displayed as the spirit layer in Google My Maps. The result is it shows on the screen. And the next method is used to evaluate the accuracy of the image decoding case set. To evaluate the accuracy of the build set of satellite image interpretation case, the study used the confusion matrix or error matrix combined with the kappa coefficient. These are two commonly used and widely accepted indicators in evaluating remote sensing image classification results. The error matrix is a comparison table between satellite image interpretation results and field verification results, from which the indicators are calculated, including overall accuracy, manufacturer accuracy, and user accuracy. Kappa coefficient is calculated according to the formula in the screen. If the kappa over 0.8 is considered excellent in classification the image in the image. Next one is the results and discussion parts. The first result is the setup decoding case. The setup decoding case were established based on the collected field surveys and the image on the satellite. The groups of water bodies comprise 27 samples classified into river, canal, lakes, and streams. The survey results show that the hydrological system of Thuận An War is quite rich and diverse, with the Saigon River being the largest water body running along the western side of the world. In the table, you can see some typical image of the different water bodies in comparison to the satellite image. Based on the features of the satellite image and the field image, we will build a detailed description to classify the satellite image. A similarity to the water bodies, the following set of satellite image interpretation case has been proposed for the remaining object groups, including traffic lane, agricultural lands, residential lands, and vacant land. And finally, we will generalize interpretive features for object groups. And you see in table 2, summarize and compare the key interpretative features of the 5 object groups. With the water bodies, you can see they are identified by their elongated or irregular shafts, dark green to dark gray color, which ranging from 20 to over to 100 meters, 0 to 5 meters shaft, and high image intensity. With the transportation length, you can see the color of rays like yellow and brown on the satellite image, with trend lines and the size from 20 to 3,300 meters. Next is the agricultural lands. You can see the dark ring flow on the satellite image. Agricultural lands consist of orchards, mixed plantation, and vegetable crops, reflecting a polycultural farming system. And next is the residential lands, include rural residential lands, urban residential lands, and residential lands combined with small workshops. They are characterized by small rectangular parcels, zero shaft, and the group colors varying from bright yellows, reds, and light blues, depending on roofing material. And finally, with vacant land, vacant land is the largest object group and represents undeveloped or traditional lands under rapid urbanization. It is characterized by large rectangular parcels, zero shapes, and variable color ranging from brown to gray to yellows and green. This is the interpretive feature for recognize these 5 objects on the satellite image. And finally, is the results of evaluating the accuracy of the image decoding case set. To ensure the reliability and applicability of the developed interpretation key, and accuracy assessments were conducted using the confusion matrix and kappa coefficient. The error matrix between image interpretation and view verification results are established in table 3. In this table, we can see that the overall accuracy of the matrix is 100% and the kappa coefficients equal equal to 1, which is considered excellent according to the classification scale of Landis and Cook. On 149 field verification points were correctly identified, with no case of misclassification between classes compared to the study applying UAV image to a land use statue mask in an urban area of Ho Chi Minh City with an overall accuracy of over 92%. This study developed a set of criteria for interpreting images for 5 main object groups into N1. Evaluation results show that the criteria for interpreting satellite imagery achieves high accuracy. On 149 addresses were accurately identified between their actual location and the satellite image. The development of the criteria has reduced labor and time in determining land use types based on actual land cover compared to traditional mapping methods. The research and development direction is interpreting artificial intelligence and deep learning into the image interpretation process. The main criteria can be used as a set of rules or training data to build automatic object recognition methods, reducing reliance on expert experience. That's for my presentation. Thank you very much for your attending.
Yes, thank you, ma'am, for the presentation.
Thank you so much. Do we have any questions?
No, no questions from me.
Okay. Thank you so much.
Yes, thank you.
Okay, with that, we are done with today's presentations. I would sincerely like to thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of the international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of World S4 2026.
Thank you, everyone.
Thank you. I would also like to thank our session chair, Ms. Sharmila. Thank you so much for chairing this session, a token of appreciation on behalf of the team of World S4 2026 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence. Ma'am, would you like to share any closing remarks with us?
No, I can just say that all the paper presenters have done a very good job, and there's a lot of hard work and effort that has gone into doing the work and presenting the papers. So all the best to all the paper presenters for all the future work that y'all y'all are supposed to do on the work. Yeah, thank you so much. It was a pleasure being a part of this conference.
Thank you. Before we all leave, can I have everyone with their camera switched on for a quick picture?
Thank you.
Thank you. Stay safe and take care.